This video is going to talk about correlation and the coefficient of determination, which is r squared. Let's first talk about correlation. We use the letter R for correlation, and it's a measure of the strength of a line, or how well a line predicts a set of data. Now you got to be careful here because R and R squared do not tell you if a line is appropriate for the data. In order to say a line is appropriate for the data, you need to actually look at the data and see if it makes a line. So correlation is a measure of strength when you're using some kind of prediction. So for correlation, it tells you two things. And correlation can be between two numbers. It can be all the way down to -1, and it can be all the way up to +1. So basically, it's a fraction, right? It's a decimal between -1 and 1. So your correlations will be something like 0.9 or -0.4, stuff like that. And it tells you two things. Number one, it tells you the strength. Now, here's the thing with strength. The closer it is to 0, the weaker it is, or the worse of a predictor it is. The closer it is to +1 or -1, so towards the ends, that makes it stronger. Now, if a correlation is exactly +1, that means all of the lines fit on a line, all the dots fit on a line perfectly. And if it's -1, that means all the dots also fit on the line perfectly. It just means that the line is going down. So the second thing it tells you is the direction. If your correlation is negative, it's going to be going down as you move to the right. And if it's positive, it's going to be going up in general as you move to the right. So I'm going to put direction/slope if you're using a least squares regression line, because that'll also tell you the slope, whether if it's positive or negative. It won't tell you the actual slope, but it'll tell you which direction it's going. So let's see some examples of what this looks like. There's some wonderful examples in your book of different correlation scatter plots. So you can see a correlation of 0, which is this first one. The dots are all kind of scattered around, right? You can't really tell a pattern. Definitely not a line. I mean, it's kind of all over the place. Very unpredictable. The next one over, you can they're still very, very scattered, but you can kind of start to see a pattern of them kind of going down in general as you move to the right. But again, very weak. And so you can see the correlation is -0.3. That's pretty weak. And it's negative, meaning it's going down. So there is some correlation, but again, very weak, hard to predict. The next one over, we can see it definitely has a pattern. It's going up in general, right? But if we try to make a line, again, the dots are kind of all over that line. Some are above, some below. I mean, it's kind of scattered around that line as well. So that is a correlation. It's positive because it's going up. But it's, moderately strong, not great, not a great predictor, but not terrible. And then the bottom three, we have really started to get really good predictors. So the next one, you can see it's -0.7, which means it's going down because it's negative. And you can see the line is starting to fit a little bit better. Dots are getting closer to that line, meaning that's a good prediction line. And then the last two are really close. You can definitely see a line here, right? And all the dots are kind of close to that. That's a 0.9. And the last one, all the dots are very, very, very close to a line. And that's -0.99. Again, if it was -1.0, that would be a perfect line. That's the best you could possibly have as far as prediction, because then everything would land on that line. You'd have a perfect predictor. So your book has this formula of how to actually calculate the correlation. It's this extremely long formula that's very, very annoying to do by hand. You'll never have to do this by hand. You'll never be asked to do this on the AP exam. But they do want you to know what it means as far as strength, what kind of values are possible, and that it tells you the direction of how the dots are moving. But you also need to know how to get the correlation on a calculator. The calculator will do all this for you. So look for a video on Edmodo of how to calculate r and r squared using the calculator. So the other part of this is called the coefficient of determination, which we label r squared. Now this is literally the correlation that you just found. You square it and that's this number. But it also has some meaning to it as well. And again, you'll never have to calculate this, but you will have to use a calculator to find it. And more importantly, you're going to have to be able to interpret what this means. They like to ask that on the AP exam. They'll say the r squared value is 0.81. Interpret this value. And there's a very specific thing they're looking for. So again, this is one of these things. There's a lot of them in this section where you just have to memorize the interpretation of what this is. So get some flashcards. Do whatever you have to do to memorize these certain things. The other ones are like slope, y-intercept, those kinds of things you're going to have to memorize specifically what they're looking for. Okay. So here's what they're looking for when they say interpret, which is a very common question on the AP exam and probably will be on your chapter tests. So if it says the correlation is, for example, let's say the correlation of determination is, we'll just use what I said, 0.81. What does that mean? What you're going to have to do is say sorry, not the, you want to put, this is a percentage, so you're going to say 81% of the variation in y, and I'm going to underline that, can be explained by x. And I'm underlining y and x because for different examples, you have to input what those actually mean for that specific problem. Or in other words, you need to put in context. You can't say x and y, you have to tell me words in its place. Now what you also need to note is r squared, oops, grab a pen here, there we go, r squared has to be between 0 and positive 1. And again, it's a measure of strength, so the closer it is to 1, the better. The closer it is to 0, the worse of a predictor it is. The only thing how this is different than r is that you can't tell the direction from r squared. So just keep that in mind. If they give you r squared, you're not going to be able to tell the direction, but you'll have some idea of the strength of your prediction line or whatever you're using to predict.